Rockridge, today's lesson is on solving by factoring and solving by completing the square. So up to this point we have learned a lot of tricks and templates for solving by factoring. We're going to use those tips and tricks for factoring to actually solve equations. Okay, so instead of just factoring expressions, today we're going to solve equations, and factoring is going to be a part of it, and we're also going to learn completing the square as a trick for solving as well. Alright, so again, we are presented with things that have equal signs now. See, all these things in the warm-up have equal signs. They're not simply expressions that we need to factor. We not only need to factor, we also need to solve. So these three steps, hopefully were easy to follow during your warm-up. Let's walk through and see how you did. So setting the equation equal to 0, that's already done for us in the first one. Second step is factoring. Well, we can do that quite easily. There's an invisible 1 in front of here, so we don't even need to do foci or slide and divide or any other tips or tricks. We just simply find two numbers that multiply to 28 and add to 11. So hopefully during your warm-up you found x plus 4 and x plus 7 to be the factors of those. Hopefully that came quickly. Now the third step is set each factor equal to 0 and solve. So let's see what happens when we do that. X plus 4 equals 0 and x plus 7 equals 0. Now we've got two very simple algebra 1 solutions. X equals -4 and x equals -7. Hopefully that went quite quickly. So these are both the solutions to that original equation. If you were to plug -4 in for x, you would get 0. If you were to plug in -7 in for x, you would get 0. Now, if you need a little bit of an explanation for why we're doing this, one thing you can think of is if you were to zero out each factor, which is what we're doing here, right? We're setting it equal to 0 and solving. If you were to zero out this factor, if you were to make that a 0, zero this out, think of it as 0 times this. Well, 0 times anything is 0, okay? And the same would be true if we move the box over here. If we zeroed out this factor, we basically zero out the whole left side. So that's why that is making this a true statement. We're zeroing out each factor so that we can make a true statement. And we're finding the values for x that make a 0 happen, right? If you were to make x a -7, that in fact would zero out this factor. So that's why we're doing this, and that's why it works. Let's look at number 2. Again, you need to set the equation equal to 0, so don't flip out about the notation here. This is just the function f of x. If you want to find the solutions to this function, you set the function equal to 0. And you factor. Hopefully you saw this as your special case of a squared minus b squared, your difference of squares, and you factored it to be a plus b and a minus b. Or in our case, a plus 11 and a minus 11. So that's the factoring step. Then we set each factor equal to 0 and solve. So a is -11 and a is positive 11. Those are the two values for which we can create a true those are the two solutions to this function f of x. Number 3, there are a couple of different ways you could approach this one. You could certainly set things equal to 0. We notice that there's a common factor here of 5, so absolutely, we're trying to dig x out of all this. So use your Unit 1 skills, whatever comes convenient to you, and dig x out of this mess, right? So let's divide by 5 on both sides because we're trying to isolate x. We have x to the 5th equals 25. Do we remember from Unit 1? Unit 1, what did we do to isolate x? Hopefully you recall that we took the 5th root of both sides so that we could end up with x equals 5th root of 25. Now I know many of you desperately want to take the square root of 25 and make it 5, but we're not taking the square root to solve for x. We had to take the 5th root to solve for x. And the 5th root of 25, there's nothing to the 5th power that I could pull out of here, so I'm stuck with just the 5th root of 25 as the solution to this problem. Okay? So make sure you recall and practice those Unit 1 skills. Alright, question 4 is a 4-term. It's already set equal to 0, so we've already got our expression on the left that we need. It's a 4-termer, and so hopefully you recall that a 4-term expression needs to be factored by grouping. So let's make a pink group and a purple group. For the pink group, what's our greatest common factor? Our greatest common factor. Hopefully you see that there's a 2 there, but also hopefully you see that there's also an x squared in both of those. So the greatest common factor is both numbers and letters. And we'll leave behind an x minus 3. We'll move to the purple group and find the greatest common factor. Hopefully you immediately see that it is negative 3. And we hope that we're going to leave behind an x minus 3, right? Because in grouping we always want these to match. And sure enough, if you were to pull negative 3 out of both of those purple terms, you would leave behind an x minus 3. Now, final step of factoring by grouping is we take the common factor as one of them, and we take the leftovers as the other factor. Alright, so factoring step is complete. Now we need to set each factor equal to 0 and solve. The left is pretty easy, x equals 3. The right has a little bit more work. So we have, if we add 3 to both sides and divide by 2. Now what do we do here? Similar to what we did up here for x to the 5th, we need to take the 5th root up here. Down here we need to take the square root of both sides to dig x out of there. Hopefully you recall that when you have the square root, when you have an even root, you need to account for both the positive and negative square root of 3/2. Now, back in Unit 1, were we allowed to leave our answer like this? Were we allowed to leave this as our final answer with a radical in the bottom? No, we were not allowed to leave this with a radical in the bottom. We cannot leave something with the square root of 2 on the bottom. Do we remember what we do to get rid of that square root? How do we rationalize this denominator? Hopefully you recall the little trick of multiplying both the top and the bottom by the square root of 2, right? If you were to multiply square root of 2 times square root of 2, you would get either the square root of 4 or just simply 2. We have now rationalized that denominator. That's proper form. The top was stuck with whatever we had, so we have square root of 3 times square root of 2, so that ends up square root of 6. And we have both the positive and negative version of that because of this square root operation up here. This is the proper form of the final solution. So make sure that if you're looking at a test or a quiz that's a multiple choice, or an SOL that has a multiple choice question, you should be seeing all 3 of these as answers. All 3 of these are answers, and you should see that this answer is the proper form of the step here that you got at the end here. So if you finish here and don't rationalize the denominator, you should know that this is the proper multiple choice answer of a rationalized denominator here. Again, I want to point out we've got a third power here. We have an expression or an equation here that has a power of 3, and that actually signals to us that there will be 3 solutions to this. We'll talk about this more in a couple of units, but there are 3 solutions to this. And we check here, we've got 1 solution here, and then we've got the positive version and the negative, so that's a total of 3 solutions. So whenever you're solving these, if you have a power of 3, you should have 3 solutions. If you have a power of 2, you should have 2 solutions. That's a little check you can do for yourself, and make sure that you circle or choose the answer that has the proper number of solutions. Include them all. Alright, number 5. We're going to use our Unit 1 skills to solve number 5. So let's see here. If we subtract 40, we're trying to dig x out. So if we subtract 49 from both sides, we get x squared equals negative 49. To get x by itself, we need to take the square root of both sides. And when we do that, x equals both the positive and negative version of the square root of negative 49. Now, is there another way to write the square root of negative 49? Do you recall from your Unit 1 efforts that this is the same thing as the square root of 49 times the square root of negative 1? Remember that? That's the same thing as the positive and negative 7. What's the square root of negative 1? The square root of negative 1 is I. So the solutions to number 5 are both positive and negative 7i. And again, we were expecting 2 solutions because the highest power was 2, and we did in fact get 2 solutions, positive and negative 7i. We'll see that come up again in a couple units. All right, number 6. Again, we're trying to dig x out of here and solve for it. So let's add 8 to both sides. Let's divide by 9. And then what do we do to get x by itself? Once again, we take the square root of both sides. So when we do that, we have x equals the positive and negative square root of 8 over 9. Once again, are we allowed to leave a radical in the bottom? Are we allowed to leave this as the square root of 8 over the square root of 9? No, we're not allowed to leave it like that. We need to completely simplify our answer, or look for the completely simplified version of our answer in the multiple choice options. So if I look at the top, let me first look at the bottom. If I look at the bottom, the square root of 9, that's actually completely already simplified. We can just make that a 3, and that'll be rationalized for us. We don't need to multiply by the square root of anything, because we can simply take the square root of 9 and make it a 3, and that's a nice rational number to begin with. So that's finished. Square root of 8, can I leave that by itself? Is that fully simplified? No, it's not. I need to take the square root of 4 outside and leave behind the remaining square root of 2. So this is the completely simplified version. So this is not the completely simplified version. This is not what you would find in the multiple choice answers. This is the version of what you would find. You'll see both positive and negative, because this was a quadratic and has 2 solutions. Okay? All right, how did you do on the thinking question during the warm-up? So let's see if we understood what we were being asked to do. If you have this expression, x squared plus bx plus 18, we want to know what numbers can be replaced with to make this factorable. Let's think about this. What could this be? Could it be 1? Could it be 2? Could it be 3? How would we find the numbers, the number choices, the multiple values that b could be to make this a factorable expression? Well, we know that numbers that multiply to 18 have to add to b, right? Factors of 18 whose sum is b. Well, what are the factors of 18? Let's list them. Well, there's 1 and 18. There's 2 and 9. There's 3 and 6. Those are the factors of 18. We could also have negative 1 times negative 18, right? And we could have negative 2 times negative 9. And we could have negative 3 times negative 6. So those are all the different combinations. Those are all the different factors of 18. Well, if those are the numbers that you'll have for your factors, if you were to add them together, those would be the possible values of b. So you would have 1 plus 18, or 19. If b was 19, this expression would be factorable. 2 plus 9 is 11. If b was 11, this would be factorable. You could factor it. 3 plus 6 is 9. If b was 9, you could factor this expression into x plus 3 and x plus 6. Similarly, if it was negative 19, negative 11, or negative 9, it would also be factorable. And the factors would be x minus 1 and x minus 18. If these numbers were replaced, if b was replaced with these pink numbers. So all 6 of these are the options, the possible values of b for which this is factorable. So we'll see that again on the exit slip for today. All right, we're going to move on to our new lesson. So go ahead and take a break, and we'll come back and look at the new lesson for today.